All right. So welcome to our fourth meeting. Today we're going to talk about logistic regression and why we need it, a little bit theoretical of what it does, but mainly we're going to focus on the code and implementing it and using it. And you'll see that this is as of the application to our data set, the Titanic data set, logistic regression does a lot better. We'll see. And we'll see why that is. So what exactly is logistic regression? So it's used to model the probability of a certain class or event existing, such as pass fail, win lose, alive dead, healthy sick, etc. These are just examples. If you think about our data set, the Titanic data set, we want to predict if people survived or not. This is sort of exactly what we want, right? The example given here, pass or fail, win, lose, alive, dead. Well, we want this, alive or dead. And so this is a classification task, a 0 or a 1. Are they alive or are they dead? And logistic regression models for this. It allows us to accurately model this type of prediction that we're doing, which is exactly what we want. There are ways to extend this to more classes. So the examples given, alive, dead, healthy, sick, etc. Those are 2 classes, 1 or a 0. You can extend this to more. It's a little bit more complicated, but it's definitely possible. So you can do, let's say you're given an image, you can do, is it a cat, dog, lion, etc. So more classes, 0, 1, 2, etc. to more. But the way, the output is a probability between 0 and 1. And if you add that all up, you get a sum of 1. All right, let's actually see a visualization of what this looks like. So this is in comparison to linear regression, right? In linear regression, we have data and we have a line. It's fairly straightforward. But we didn't get, if you remember from last lecture, we didn't get that good of an accuracy, right? We got like 0.4, I think, which is not that good. It tells us that the correlation between the inputs and the outputs is not that high. It's not that strong. Well, we can see that the reason for that is because what we're trying to predict, if they survived or not, is not meant for linear regression, right? We have our y-axis right here. We have our, if they survived or if they didn't survive, they're a 0. If they did survive, it's a 1. Well, you can see linear regression just doesn't really model for that. It can't really tell the correlation between these two because of the categorical nature of what we're trying to predict. Is it a 0 or a 1? Did they survive or did they not survive? How logistic regression works is it's this curve-like nature. And you can see that logistic regression pretty well models for our what we want pretty well. You can see the survived or not is this function right here, this portion of it, as well as the other part of it. And so this is on probability. It's from 0 to 1. And essentially, if, let's say the model predicts a probability of 0.5, right? Because it can be any number from 0 to 1. Well, what we do is we round this up. We round the 0.5 to be a 1. And if the model predicts anything below that, then that goes to it being a 0. And with doing this, we can predict if it's a 0 or a 1, if they survived or if they didn't survive. And logistic regression models for this type of classification task. What is the probability of some event occurring? Whereas linear regression is powerful, it's a good tool, but for our particular task, it's not what we need. And so just a quick look at the math, it's fairly straightforward. It's pretty similar to linear regression. We have our line, y is equal to m1 x1 plus m2 x2 plus the bias, the y-intercept, right? This is just linear regression right here. But we have this right here. This is a sigmoid function. And if we graph this, don't worry about the formula, but if we graph this, this is what it looks like, this curve right here. And if you notice that this is between 0 and 1, it's some probability, some distribution, some probability between 0 and 1. And so given some input, right, let's say the input is a 2, it's going to predict, like, let's say this is 0.8 right here. And so because we're doing a classification test, this 0.8 would round up to a 1. And so we would predict the output would be the number 1. Similarly, if it was below 0.5, the output would be a 0. You can see it's linear regression, but between two, like compressing it, right? Linear regression was just a line, and it could go on to infinity and negative infinity. Whereas in this case, it only goes from 0 to 1. And this allows us to predict classifications. And then finally, this is our function, this sigmoid. But the actual prediction of logistic regression is this. This is the actual like combined formula. It's just our linear regression as the input to our sigmoid function. This entire thing is inputted as the y. That's it. It's just linear regression, but compressing it and making it between 0 and 1. And doing this allows us to model for these types of classifications between 0 and 1. And again, the way it finds these aren't too important. It's not the same as linear regression, right? Linear regression was using least squares regression, basically calculating the distance between the error and the prediction. It does that too, but it does it a little bit differently, logistic regression. And so it's not too important to know how it does it, because it's done all for us using that library that we'll use. And so this is the meat of what we're going to do today, the code. We're going to jump in because this is the interesting part, I think. And we'll start off with the R part, but if you remember last time, I recommended R for the linear regression. This time I like Python a lot more, and we'll see why. But R is also important for knowing which variables to use. And so let's go into our R. All right. And so we have our IDE right here. And again, I've already changed my directory to have the 2 files available. Again, similarly, like we've done in the past, df, we can call that whatever we want, is equal to read.csv and our train.csv. And that loads in our data. And just to check it loaded in correctly, we print out the first 5 and then load it in correctly. Now, R is pretty simple to do the logistic regression. We'll do reg, we can call that whatever we want, is equal to glm. glm, we can't call. This has to be glm. And if you remember, this is a little similar. The linear regression was just lm. But now we have to do glm for the logistic regression. And that's going to be the same thing as the linear regression, df of survived. Let me spell that correctly. And then tilde, the little tilde. And then df of the variables that we want. I'm going to use this whenever you guys are doing your own projects. This comes from experimentation. Try different things. And then I kind of explained this last time, but I'll go over it again. How do we determine which variables we want? And starting off, you can just start off with every single variable. Try all of them. Some of them have to be by context, right? The name is probably not important, so you probably don't want to include that. But other things might be important, and so just try it out, experiment with it. But for now, I'm just going to do the sex. And then remember, to add more variables, we do plus df of age plus df of, I'll do the number of siblings they have, plus df of what else did I want? The P class, so which class they were in. And then we're going to do comma data is equal to df. Remember, df is where our data is stored right here. And then this is very similar to the linear regression, but what's different is we have to do another comma, family is equal to quotation marks binomial. And this tells R that we want to use the logistic regression. We press enter and we don't get any errors. And then we're going to call summary of REG. And we get this whole intimidating file text right here, but pretty similar to what we have with linear regression. And this is why I don't like the R. It doesn't actually tell us our accuracy in this case. And there is a way to find out the score or the accuracy we get, but it's a little bit more complicated. And we won't go into that. But the power of R is right here, where it tells us the significance of our variables. Right? We kind of talked about this last time, but I'll just go over it again quickly. That we have this right here, this P probability, this column right here. And this tells us if our variables are significant or not. And we can see here that if we have these stars right here, it's telling us that every single variable here is significant. If we don't have that, then what we would want to do is remove these variables. For example, let's say the number of siblings is not significant. Then we would want to rerun this model. So do the same thing, but just get rid of the number of siblings. And the reason for that is because this tells us that siblings are not significant. And we want the least number of variables possible, or the least number of variables that'll improve our model. And the reason for this is because the variables that aren't significantly contributing to our model might artificially boost up the score. And we don't want that. We want our score to be as high as possible, but without all the variables, and with the least amount of variables possible. And that's called overfitting, basically, when you have a lot of variables, but they don't contribute to it. And so you think your model does good, but then when you go to test it in the real world or on a test data set, it doesn't do as well. And so, but we can tell that these are all significant. And so we'll use this as well for the Python version. And so this is all I want to show for the R version, just to show that this is how we find the significance. But the Python version is where the exciting part comes in. Let me go back. All right, I'm gonna go with Colab again. If you're using Python or Anaconda, this will work as well. But we want to first go do or import the files that we want. And for today, we're going to import both of them, both our train and our test. And I'll tell you guys why later. So we'll add those files in just so we can access it. All right, next, just like we've done in the past, import pandas as PD. Run this. df is equal to pd.read_csv, our train.csv. Just to see if it loaded incorrectly, print df.head, and we can see we get the first 5 and it loaded incorrectly. All right. Next, we're going to use the same variables we did with the R. So the sex, the age, the P class, and the number of siblings. We're going to use that. So let's actually just put that into an array so we can access it later. Columns is equal to the sex variable, the age variable, the P class, and the number of siblings. All right, now what we want to do is, if you remember from last time, age had null values in it. Let me show you. So df, so print df of age dot unique. And so you can see this NaN. These are the null values. Python can't handle for this, so we need to convert this to integer values. And if you remember from last time, there's nothing new. This is from last time, but we do df of age is equal to df of age dot fill NA. And this fills in the null values with, we want to fill it in with the median. And so we'll do df.age.median. And this fills in, so if we actually print out the unique values, we see we no longer get any null values. Again, this is from last time. The sex variable had male and female. We can actually print that out. Male and female. Again, Python can't handle for this, so we need to convert it to integer values. And so the way we do this is df.loc, and this locates whatever we give it. df of sex, which is our variable, equal to male, comma, sex, just so we can return just that column. And we're going to set this equal to 0. And we'll do the same thing, but for the female. Again, there's no point memorizing this. You can just look this up. It's very easy to look up on Google, but just understand why we're doing it, and just know that you'll have to do this with your own data sets. But there's really no point in memorizing how we do this. The code, because it's easily lookupable. But we run that, and then we print out the unique values, and we see we get 0 and 1 instead of the male and female. All right. Now we're going to get into our logistic regression. And so we're going to use sklearn, which is what we did use last time. From sklearn dot linear underscore model import logistic regression. Last time we imported linear regression. This time it will be logistic regression. Next, we're going to assign, we'll assign this. So reg, you can call that whatever you want, is equal to logistic regression, parentheses. All right. Now, logistic regression expects the x-axis and the y-axis. And so we'll actually make that now. X underscore train is going to be equal to df of columns. What is our columns? Remember, columns is sex, age, p-class, number of siblings. And so what this is doing is accessing the data frame, but only with the columns that we want. And the y train is going to be df of just survived, because this is what we're trying to predict. All right, now what we're going to do is reg is our logistic regression dot fit. And then we're going to fit the x train and the y train. And we see we get this output, sort of meaningless, but how do we access the score? It's a little different than R, right? R, we could tell which variables were significant, and that's the power of R. We could do that with Python too, but it's a little more complicated. With R, though, it was more complicated to find the accuracy. How do we know if what we got, what our accuracy is? And the way we do that is print reg.score, and then we'll also input the x train and the y train. And we get 0.79. If you remember from the linear last time, the linear regression, we got 0.4. It's pretty bad. That's telling us that the linear regression model was not accurately predicting who survived or not. 0.79, almost 0.8 is not bad. It's pretty good, actually. It's pretty close to 1, which is telling us, it's somewhat close to 1, which is telling us that it's somewhat accurately predicting if they survived or not. And so this is telling us that our model is not bad. This is pretty good. So now that we've made a pretty good model, what do we do next? We have the competition, right? The Titanic competition. Let's submit to it. We found this decent score. Let's submit to that and see what we get on the actual test data, right? because this score is for our training data set. But we have test data right here in our test.csv. That's what was provided to us. And so let's try to submit to Kaggle, and Kaggle will tell us how well we actually did. And so, well, let's access our test CSV right here, test.csv. And we'll do pd.read CSV test.csv. Right, same thing, just reading the CSV. But instead of the train.csv, it's the test.csv. Let's actually see what we get. Test df, test underscore df dot head. And we get the header of this. Let's actually look at the columns for this. Print the columns. We get passenger ID, P class name, sex, age, siblings, parts, ticket, fare, cabin, embarked. You might think this is exactly the same. I've touched on this before, but this is not the same as the train data set. Because let's print out the columns in the training data set. Passenger ID, okay, we have that. P class, we have that. Okay, name, sex. But what we don't have is survived. Inside the train CSV, we have survived. Inside the test CSV, we don't have survived. And the reason for that is because Kaggle has the survived. What we need to do is predict if they survived or not, and then Kaggle is going to tell us how well we did, because they have this survived, and we can't access it. And this is a common approach. We want to know if our model actually learned or not. And so we test it on data it's never seen before. Right? This test.csv, it wasn't included in the training data set, so it's never seen this test CSV. All right, so let's make our prediction of the test data set. Before we do, we have to do exactly the same thing we did with our training data set. If you remember right here, we changed the sex to 0 and 1, and we also filled in the null values of age. We have to do the same thing. I'll just copy paste. What we're going to do is fill in the null values of age. But instead of the test, instead of the train.csv, it will be of the test.csv. And so we just convert all of these to test. Next, we convert the sex to zeros and ones instead of male and female. And again, instead of being DS, it'll just be test DS. Same thing that we did up above. All right. Now what we want to do is make our X and Y variables. And the way we do this is X test is going to be equal to our test DS, not our DS, but our test DS of our columns. Remember, columns was our sex, age, number of siblings, P class. And our Y test, we don't have a Y test because we don't have access to the survived, right? The DS has the survived, but test DS doesn't have survived. So we don't need that. We actually can't access that, and that's okay. Are there any questions, by the way, before I move on? All right. So this gives us our test data set from our test.csv. Now we're going to do the same thing. But using the regression model, remember, REG was our logistic regression model that we trained. It learned. We're going to do REG dot predict X underscore test. And then we'll store that to prediction is equal to. What this is doing is predicting. It's using the model that we trained, right? We trained the model right here, reg.fit on this data, on the training.csv. Now we're testing it. How well and predicting on the test.csv. If we print out what that looks like, prediction, it's a bunch of zeros and ones. This is exactly what we want. What this is telling us is that person 0, or the first person, let's just say, for first person, inside our test.csv, there's a bunch of data on that. The model predicted that they didn't survive. The fifth person, it's predicting that they did survive, and so on for all of the different values that we have inside our testing CSV. All right. Now we have our prediction. How do we submit to Kaggle? This is what we predicted. How do we submit it to Kaggle? We need to look at Kaggle a little bit. What does it tell us? This is the again, the Titanic website. Just go to kaggle.com/c/Titanic. If we go to our data tab and then go right here, we see an example submission. This tells us what exactly does Kaggle want. It wants a passenger ID and it wants the survived. Okay, we have the survived. It's what we just predicted right here, this entire thing. We also have the passenger ID. It's inside our test DS right here, passenger ID. We need to combine those into a CSV file to submit to Kaggle. The way we do that is we'll have our data set. We can call that whatever we want. Is equal to PD, again, that's pandas, dot data frame, all right, parentheses. And then this is probably the most confusing part, but I'll break down the steps. We're gonna have list inside of that zip, and then inside of that, we're gonna have the test DS of passenger ID dot to, I'll break all this down, so don't worry about it if it's confusing. Dot to underscore list, comma, the prediction dot to list, not underscore list. And then we're gonna have the right over here, I believe. No, right here. Columns is equal to passenger ID, comma, survived. And again, I'll break all this down, but let's just see if it, yeah, no errors. Okay. What the heck is going on right here? Let's start off with testDF.to_list. TestDF passenger ID. We know that just accesses the passenger ID, right? This is just the IDs of the passengers. To_list, what does this do? And dot to_list. It just converts it to a list. We get a one-dimensional array, a one-dimensional list. All right. All right. What does prediction.toList do? Right now, prediction is it's called a NumPy array. It's just using another library. Just for ease of use, we're going to just convert that to a list. And so again, the same thing. We just convert that all to a list. So we have two different lists right here. We zip them together. And again, this is, again, sorry, probably the most confusing part, but this zips up the two lists and makes it into a zip object. And so this isn't sort of not readable, but this is combining the two lists together. And then finally, what list does is it converts the zip object into a list. And so the output of that we'll see is this list, this array. But as you can see, they're combined together. For example, passenger 1084 didn't survive. That's the prediction. Passenger 1088 did survive. That's the prediction. And so all this is doing is making this array of a combination. The reason we're doing this is because pandas needs to make we want to make the CSV file. And so what we're doing is just putting that list together and then telling pandas that we have these two columns, passenger ID and the survive. These have to be spelled right. So just be careful they're spelled right because that's what Kaggle is expecting. But now let's print out the dataset.head. And we see we get a data frame of two variables, passenger ID and survived, and of whatever we gave it. And this is what we want. This is what Kaggle is expecting. And this is what our prediction is going to be, what we'll submit to Kaggle. Okay, but how do we convert this to a CSV file? That's what Kaggle is expecting as well. We need to take this data frame and make it a CSV file. What we do is data set, that's what we call this, dot to underscore CSV. And the first thing that we do is pass in the file that we want to name it. We can name it whatever we want, but I'll just call it submission.csv. You need this .csv. And then we're going to set it comma index is equal to false. Okay, what is this index equals false doing? If you see these 0, 1, 2, 3, 4, what index that equals false is doing is getting rid of that. We don't want to count this. The reason for that is because Kaggle will actually give you an error. It'll tell you that it had this undefined column, and which it wasn't expecting. And so all this is doing is getting rid of these. And so we do that, and we go over and we see we have a new file, submission.csv. Let's actually download that, save it, and then save it to wherever. I've already saved it, but I'll save it again. Now we'll go back to Kaggle. We have our submission, and let's actually look at it, what it looks like. But we actually did it. It just looks like a regular, we just have the passenger ID. Let me share it my screen. See, it's just a CSV file, an Excel file of the passenger ID and the survived with the corresponding if they survived or not, which is exactly what Kaggle is expecting. They want the passenger ID and they want the survived. Now what we're going to do is, I'm assuming you've signed in. Go to the submit predictions. All right. And now you're going to have nothing here. I submitted this just as a test, but scroll down to upload submission file. Click this. And then you'll go to wherever you stored your submission and open that. And you can see submission.csv, and then describe your submission. You can describe whatever you want. And then click make submission. And Kaggle is going to score that for you. And then finally, when you go up, you're going to see submitted just now, and the score of 0.75, which is not bad. The maximum score you can get is a 1. So 0.75, this puts us in the, if we jump to the position of the leaderboard, this puts us, and here you go, in the 180th position, which is not bad, right? There's a lot of people doing this competition. So being 180th place is not bad. And so this is the submission. This is how we submit. And we can see that this is logistic regression. It's meant for what we're doing, right? The context of the task that we had worked for us. Logistic regression was what we wanted. And using that, we can see that we got a pretty good score. And I hope that this showed that this is how we submit files to Kaggle. This is how we do competitions. And there's a bunch of other competitions. And I encourage you guys to explore them, to find what you're interested in and to look through. But I hope this was helpful. That's all for me. Let me know if you have any questions. And thank you for coming. So let me stop recording.